right? But we need to get in as much possible. So by Friday, Saturday, I think we'll be done with that. You will see what I mean. This file, this is, you can check it. This is the specimen papers that I promised you. Okay. Take out that other letter. We are going to look at that specimen paper in a minute. You remember the one letter that I gave you, the one from the Ministry of Education? This one. Okay, you just need to highlight a few things for me. Yeah, this one. So that is the specimen papers. It has got answers also, alright? So that is how your examination is going to be more or less. So we'll talk about that now. Just want to quickly look at this letter before we start the lesson. Now, this paper that you have, page 2, page 3, page 4. These are the, it says, find the list of mathematics AS formula and notations. List that will be given to the candidate as part of the question paper. It will be given to you as part of the question paper when you write the exams. This is the only list of formula and notations that will be given to you. If you are found to have additional formula during the examination, please, I'm warning you now. Friendly warning. Don't take your own formula in the exam. Otherwise, your results will be declared null and void. They will be nullified. You understand me? It's very serious. The only things you carry in is whatever is written on the question paper. So sometimes additional material, they will say NF9. If you look at your specimen paper, the stuff that they will tell you that you need to be able to take in the venue. So, for example, this is paper 1, the additional material, non-programmable calculator, and then a list of formula which is in there, right? You don't carry it in there. So please, the other stuff is basic pencil, whatever, all right? If you want to have your instruments with you, but you're not really going to draw anything to scale, but just have them handy. I don't know. All right. Then there are some few what we are doing now that I want you to highlight. So you look at binomial expansion. You highlight that, and also the one under. Just highlight binomial expansion. The whole long a plus b raised to the n. Also highlight and the operations. The last one, the operations. You have got n factorial on page 4. I guess that the operation of the sigma, you are fine, you don't have a problem. The operation of the square root of a, if you are given like that, it means the positive root of a. We are going to do absolute value, so the modulus of that real number. N factorial, that's how that one is, right? N factorial. Alright, and n is an element of all natural numbers. And 0 factorial is equal to 1. We're going to come to that stuff. Then you have n, Rn, choose R, NCR. That is the formula. We're going to look at it. You can also highlight it. I'm saying you highlight it because it's pertinent to the lesson that we are doing as well today. So I have communicated to you, please remember, the exams. So whatever you, the exams you're going to write now, paper 1 that you're going to write now in April, okay? You also not carry it on the paper is attached. Although some of the stuff we are not yet done, it's just going to be attached, it's just formality. When you look at, and I'm going to use this as an introduction. when you look at question 5, on this paper, the specimen paper that is there, it's, I wrote it down the other day. So it says in the expansion 3x minus 4 all raised to the power of 4. Find the coefficient of x. So we're not going to take that bracket now and we're going to, multiply that same bracket by itself and just look at what the coefficient of x is. You can do that if you want to, but it's going to be a horrible number. Okay? Now, I'm going to do it, and then I'm going to do the rest. It's going to be what we do up to 1 or something like that, and then we're going to continue from there. So then maybe then it will be clearer how you get it. So the way I would advise you to do this is take the terms in here and swap them around. Because we are interested in that polynomial of x, the term that contains x. You understand? Now, while I have it here, let's just start from the beginning. So we're going to do this. So we have got a raised to the power of 0, that gives you 1. A plus b raised to the power of 0, that gives you 1. A plus b raised to the power 1, that obviously will also give you, the coefficients will be 1, 1. Maybe for the sake of clarity, I will just write them like this so that you can get an idea. I'll come to this. So a plus b is just going to be, a plus b raised to the power 0 is going to be 1. See, I'm using the identity. Then a plus b raised to that power 1. But of course, this is just going to be a plus b. Then a plus b all square is going to be a plus a squared plus 2ab plus b squared. Then a plus b cubed. Remember Pascal's line? A cubed. This one should be the same. Plus 3 a square b plus 3 ab squared plus b cubed. I'm interested in the coefficients. A plus b raised to the power 4. Okay, so that's going to be a cubed. I always know there should be a 4. There should be a 3, there should be a 2. Always know the next thing should be a 4. So that one is 1, 4, 6, 4. Right? 1, 4 square b plus 4, 6, right? A b squared. And then we go down again. 4, well now this is a 4b. Am I right? B squared, b cubed. Plus b to the 4. Is there something missing?
Yes, I started with a cube.
I started with a cube. I'm supposed to start with a. No, that one is fine. A to the 4th, a cubed, a squared, and here we're going to have a b, the b squared cubed. It's fine. So also we do know that the sum of the indices, they should give you the same value there. We did that yesterday. So this gives rise to Pascal's triangle, where you have the 1 there, you have the 1 and 1, you have the 1, the 2, and the 1, you have the 1, 1, 3, 3, 1, then we are here, right? We have 1, then it's 4, 6, 4, 1. So we expect this also to have the same coefficients, right? The value here of b is the 3x. I just swapped it because we want to deal with that x. You understand? That's what the question is asking there. Just something else now. And I want to bring in this notation. Finding these coefficients. Right, so the way we have our formula so far, we have a plus b raised to the n. So it's going to be the first one, a to the n. Are you with me? Then b to the 0. Plus a to the n minus 1 because it's decreasing. B to the power 1 plus a to the n minus 2. It's very important because we're going to talk about the terms and then we're going to do the general term. And then we have b to the power 2 plus, let's do one more, n minus 3, b to the power 3 plus dot dot dot. So what is the final one going to be? The final one, what will it be? It will just be b to the n. Like for example. Yes.
So why don't we just say the b like use also n like b use raised to n.
B is
Instead of using just
b is raised to n.
like n plus 2 n
No, I want to make it a bit different. I want to have 0, 1, 2, 3. There's only that. You will see what I mean by that. Right. So there are a few things. My formula is not yet complete that I have left out. And these are obviously the coefficients. Are you with me? Now to find those coefficients, like we have seen, when we have got a to the power 4, the coefficient here was 1. Even the last one, the coefficient was also 1. Right. So there is a way that we can find these coefficients. And we're going to introduce you to what we call NR, which is a vector way or method of giving the same notation. So I'm introducing you to some notations, right? Which is the same as N choose R, or you can even get them as NCR vertically, horizontally like that. There are many ways that you can deal with that. I like to work with NCR. Okay? When you are dealing with this, the top number is obviously going to be these values that you have. The top number has to do with this power that whatever you raise this to. So if you were to take, for example, your calculator. Now, before we look at that, the formula that we're going to get, and this is how you read it, I just ran out of space there, right? So we can have NR, or you can write NCR equals to, or sometimes something like that. So this is the notation. This is actually what is in your syllabus. But this is the notation that we commonly use, all right, for the purposes of what we're doing, right? So it is factorial n, okay? That's how you read that. Divided by, now I'm just going a bit different, but you can do that if you want to. The R is a number under, right? So you can go n minus R factorial multiplied by factorial R. Okay? So, in your book there, they start with calculate things like factorial 9. What does it mean? It just means 9 times 8 times 7. You understand what I'm saying? Or factorial, let's take 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then you get something like this. 10 factorial divided by 10 factorial. It's like the same number. If I have to write 9, 10 factorial will be 10 times 9 downwards, divided by the same thing. So what is this answer going to be equal to? It's going to equal to 1. Don't you agree? Don't you agree? Okay. Now, there's also a very key definition that we are going to give you. And you need to know that when you define 0 factorial is equal to 1. It's very important that you know that. It's not equal to 0. Alright? 0 factorial is equal to 1. So, what would something like 5 factorial over 0 factorial be equal to? It will equal to 5 factorial. Because it's like 5 factorial over 1, which is just equal to 5 factorial. That makes sense? When you have the 0 there. Alright? So by definition, 0 factorial is equal to that. But we also realize that 10 factorial over 10 factorial is equal to 1. So this is a way of writing 1, and this is also a way of writing 1 like this. So, if I am now working with this one where I have 4, and I'm going to write it as, that is a vector. Maybe because I'm running out of space, I'll write it as a vector, but let me do that a little bit later. If I want to find this coefficient of 1, right? So here I'm going to have, remember, on top you have got 4, choose, but what is this going to be? 0. How you see something? This is the first term. Let me use a different color. Pink. And I'm going to come back to the terms. Right? This is the first term. This is the second term. This is the third term. Fourth term. And we're going to talk about the nth term, the general term. Okay? So, if that is the case, you will realize that you get an answer of 1. We're going to do that. Let's do this without using a calculator. So this, for example, becomes 4 factorial divided by 4 minus 0 factorial multiplied by 4 factorial. Now remember, 4 minus 0 is just 4. Then basically you have got something like this, 4 factorial over 4 factorial times 4 factorial. You understand? N minus r times r, sorry, times 0 factorial, right? It's here. N factorial, then subtract them, times r factorial. This answer is just the same as 1 over 1, which is going to give you 1 when you calculate it. Okay, right. So that's 1. Now let's come back here to this one. Because by definition, if this is 1, then this will be 3, choose 0. Will give you 1. 2, choose 0. 1, choose 0. What will that one be? That's like 0, choose 0, right? Isn't that so? This is going to be like 0, choose 0. Okay, let's work with this one as far as concerned. We're going to take the other one, right? Because that one can be anything. Now, this answer is also 1. This coefficient. So it should be 4, choose 4. Because that's what we did again. Now check it. You can calculate this quickly in your calculator, right? So on your calculator you have got on the division button. So you choose 4, pick 4, then press shift, and then press 4 again. Obviously you're going to get an answer of 1. Now remember it's there now, right? So we're going to get the other ones. We're just going to go back. Let's just get, so by natural, this one is also going to be 3. You can also say 3C3, no problem. This one will be 2C2. This one will be 1C1. You understand what I'm saying? So all of these are going to give me 1s. If you calculate this, you get a 1 as an answer. Now, because I'm running out of space, when I come here, I'm going to write it as a vector. You understand? So I am going to write, in this case here, I'm going to write what? N what? 0. For example, is it not so? Is it not so? This is NC0. N is whatever this is, like 4C0. Is it not so? Okay. So what would this coefficient be here on this side? N over N, which is just 1. Is it not so? Good. So naturally then, this one here should be 2C1. Now, you can check on your calculator that the value of 2C1 is equal to 2. This one here should be 3C1, 3C2. This one here should be 4C1, 4C2, If you punch that in, you're going to get 4 is an answer. That's going to give you that coefficient. Punch this 4C1, you get 4, right? Punch 4C3, you get 4. You get it. Do we get it? Are we together? Not too fast? We are together. Alright? So, what would the term be here? What would the vector be here? N1. See, I can write it as C, but I don't have space, so I'm just now writing it as a vector, okay? But you can also do that. Yeah? So, this side is going to be, this side is going to be what? N, choose 2. This side will be N, choose what? There's a plus there. And obviously we have that. The last one. N, choose what? N, choose what? Whatever the last one will be. Okay, so I'm going to leave that as the same. So when you are looking for the coefficients there, we're going to use this stuff. When we do that, we're going to come back to that. I just want to talk about something quickly. Let me give you an expansion, and I say we're supposed to use this and find and write it out. So in the textbook, let's find the question. What happened to mine? Let's say go to page 43, 86 I think. Here they are saying find the first 4 terms, find the first 4 terms. Okay, let's take a plus 2 raised to the power of 12. But we are only, because remember, by the way, let me ask you a question. How many terms do you expect your answer to have here? It's always one more than that. Huh? So we have 1, 2, 3, 4, 5 terms. So when you are given something like, which part can I take away? I can take this away, right? When you are given something like that one, a plus, what is it, plus 2? Raised to the power of? And they want us to find the first 4 terms, right? So remember this one goes up. Yes, are you with me? And also my vector will be 12C0. Are you with me? 12C0, right? And then this goes A raised to the power of 12, B, or the 2 here, the 2 raised to the power of 0.
Yeah, because
Plus. I'm going to use the same notation as when you guys find this. Remember, this is just going to be 1.
yeah,
Alright.
12 to
Then 12C1, then A raised to the power of 11, then 2 raised to the power of 1. The indices they should add to that.
yeah,
Then 12C2, A to the 10, then 2 raised to the power of 2. Now they said we must write down the first 3 terms of 4 terms. Good. So, first term. That's the first term. If I have to write down the first term, it's only 3, right? Okay, so it's 12C3, A to the 9, 2 cubed. Are we together? Plus, and so on and so on. You see that? It's going to be more, right? We expect to, if we have to really do this, we expect to have 13 terms. Is it not so? What will the 13th term be? What will the last term be? 12C 12, and then B, that 2 raised to the power of 12. You understand? That in fact, that last term will be the term that does not have a variable x. That will be the one that is independent of the variable. We'll look at those type of questions later. Let's just clean this up, right? We know that this is 1.
Yes.
And this is just A raised to the power of 12, and then it's 1. Are you with me so far?
Yes.
We know that 12C, that is going to give you what? 12, because remember I said Pascal, so it's 1 then 12. If it's a 13, 1, 13. So this is going to be 12, 8 to the 11. But now, I'm going to have times 2 and 8 to the 11. Are you with me? I'm going to finish calculating. Plus 12C2, that gives you what? 66. You have 66 times 4 comes from 2 squared. Times A to the 10. What is 12C3? 220. 220. Times 8. Are you with me? Times A raised to the 9 power. Plus and so on. So now if we clean this up, this is A to the 12 plus 24 A to the 11. Are you with me? Plus 66 times 4, 264 A to the 10, 220 times 8, 1760 A to the 9 plus dot, dot, dot. How many terms do we have here? 1, 2, 3, 4. The question matters only to find the first 4. And so you can go and ask the first 3 terms or whatever. Do you understand? Using that NC. So I could also have written as 12, 0 as a vector, 12, 1, 12, 2. But I want you first to master this. Choose. Right? Read it as 12, choose 2. Or just say 12, C2. You understand? Everything is fine. Now, before we look at that, if this question was asking you to find the coefficient of something, like if I ask you to find the square coefficient of A, then it will be something else, like what they're asking here. So we're going to use now what we have learned to solve this, right? So this one is saying 3x minus 4 raised to the 4th power, the binomial expansion. Find the coefficient of x. Now you see what I did here? I swapped them around. There's a reason for that. Let's just come back to something very important, and that is a general term of, because this is a sequence, right? This is the first term. We know what the n is. Are you with me? Maybe we should look at that. Maybe this will give us an idea. This is the first term. Second term, third, and fourth. So this is the first term. This one here, second term. This one here, third term. This one here, fourth term. Term. Good. When you are dealing with 12C or NCR, right? When we are looking at NR, that part, or the NCR, this part that I'm talking about. When we are looking for the terms, we are looking for, this is the first term. There are certain things I want you to take note of. So we are going to write the general term for the sequence. Right. The first term, if you look at the 12s, obviously the 12s, they come from there. Does that make sense? But when I talk about the first term, can you see that the R is equal to whatever is on the B vector? Right? This is the second term. But can you see the R is what equals to that? So the R is 1 minus whatever the term is. Are you with me? This is the third term. But you see that my R vector is 2. And whatever is on that B will be 2. Do you follow? So if you have to pick the third term from there, let's pick the third term. The third term here is nothing but, for this particular one, the third term is nothing but 12, 2 divided into the vector. Alright? Then you have A to the 10 and 2 to the power 2. Now here's the thing. I can pick them. The third term, when I write the third term of something, the 12 comes from if I'm given. But it's always, the R value is always 1 less than what I'm given. So I'm going to write it as follows. In A, I'm going to have N minus R. If you look here nicely, that this 10 is we get this 10, because now we know that these two should give you 12, right? So I know that in order for me to get this 10, I can say then it's that 12 minus what? Minus 2. But remember the 2 is R, right? So here it's going to be, if I'm talking about in terms of AB now, so that is N minus R, and here I'm going to have B to the R. Okay? Where here I have what? What do I have here? NR. N choose R. So T should be R plus 1. Where this is nothing but 1 plus N plus 1 N third. R plus 1 third. So if I ask you to find the 7th term, for example, if you have to find the 7th term, then you say R plus 1 equals to 7. So R should equal to 6 because it should be 1 less. So for this particular expansion, the 7th term is going to be T7 will be 12 on top, but my R should be 6. So I'm going to write it like that. If I say I'm running out of space, then I have, now you see, this 2 should have the power of the 6. Are you with me? This 2 should have the power there. This 2 should have the power there. This 2 should have the power there. You understand what I'm saying? So now I know that that 2 there should be raised to the same power as here. Then the one on top, the A then, A will be then 12 minus what that 6 is. Because together they must give you what? Then now, if you want to clean it up, you can calculate it. You can find 12C, 6 on the calculator, times 2 raised to the power of 6. And then you get that value. So get me that value quickly. So you say 12C6, whatever it is, times it, as it is there, 2 raised to the power of 6. What is the answer? Good, it's a horrible number, right? So I'm just going to leave it like that. 69 blah blah blah, okay? I'm running out of space. So I want you to understand, when I'm talking about the general term is going to be N choose R, where, because it's still in terms of A plus B, A is N minus R and B is R. This is the general term. If I say what is the 7th term, what is the 8th term? But then there's a little problem. Not really a problem. So you need to understand the difference of how the questions are asked. They are saying, find the coefficient of X. You understand? You don't know what term X is. Number 1. Do you know what is the term X? X is which term? You don't know. Right. So if we have to find the coefficient of X, it is, the X is here. That's why I had to swap them, because that's going to be like a number, but the X is here. So we want that X. When we do that, when we use our NCR, we have to find the coefficient of X where the highest power is 1. So the problem here lies with what? R. We don't know what R is, but we can calculate R. Just pause for 1 minute. Register class. It's not a register class. Why are you? Huh? What are you doing in my class? You are writing explanation in your hall. You are doing math. Does this class look like the whole thing? Go to Miss Ken's is waiting for you for 9 hours. Yeah. I want to take away something. I'll come back to that question. It's very straightforward, very easy. Alright? Just how to work that R that we have. In fact, can we write down, let's say, the first few terms, and then you arrive at something. So this will be 4C1. Okay, I'm going to write that. It's out of the scope here. I can take this off, right? I just want you to look at something, right? So let's take this and we're going to write 4C0.
Yes.
Okay? Remember, this is now my B and that's my first term. So this one is increasing, right? So it's minus 4, it's increasing. And this one here, the 3x, will have the same as 0. Plus 4C1. I'm going to stop somewhere. This holds out, you can do it. Then this one is now going to decrease. And this one here will be. Is it still necessary for me to continue? Look here. If you calculate this, anything raised to the power 0 will give you 1. But here you're going to have something with an x. The next one will have an x squared as a coefficient. So there's no need for me to continue. There's also no need for me to do this too. Do you understand? So in order for me to find that term that will have x, I will have to choose where the coefficient of the x will be a 1. So I immediately have to go to 4C1. And 4C1, this is why I have to swap so that I can have the term with the x. You understand? So 3 raised to the power of x, somehow it has to be the same as this. Then the number here, which is the negative 4, should be cubed because you get it by saying 4 minus 1. Do you follow? This here is going to give me that term. And then we'll just calculate the coefficient. In fact, let us calculate 4C1 is 1. It's 4. Are you with me? Times negative 64 times 3 times x. You know where 4 comes from, right? That's 4C1. You calculate it, right? And that is negative 64 times 3. So what is the answer? Negative 768x. That's the answer, right? When you multiply those things together. Therefore, the coefficient of x is minus 768.